Okay, so Unit 3, Lesson 3, so rational and irrational numbers. If you had me for Math 9, we did go rational and irrational numbers. I'm actually doing it right now. It's the first unit. Okay, so just talk about just the general idea. I think this book actually explains it better than what you guys may have learned. So it says convert 28 over 11 to a decimal. So 28 over 11 to a decimal is 2.545454, so 54 repeating. Okay, it says circle the correct alternatives in the following statement. The decimal represents 28 over 11 has a repeating or non-repeating. Well, I kind of gave it away. It's repeating. Okay, and it does terminate or does not terminate? Does not terminate. Good, Mike, it keeps going, right? So, okay, that would be 28 over 11. Convert 28 over 8 to a decimal. So 28 over 8 to a decimal is 3.5. So 20 over 8, is it repeating or non-repeating? Non-repeating. Does it terminate? Yes. So it terminates. Okay? Then here's where things get, here's the other. Okay? Root 2. Root 2 is 1.4142135 and keeps on going. Okay? Is it repeating or non-repeating? Non. Does it terminate? No, it does not terminate. That is what makes it a rational number. Okay? If you have a repeating decimal or terminating decimal, it's a rational number. If it's a non-repeating, does not terminate, it is a irrational number. Irrational numbers are very rare. And last year, like when I was telling you guys, it's very hard to what's one from the other because the irrationals don't come up very often. So the other very common one, which we've used quite a bit with surface area, was pi. Pi is a very common irrational number because pi goes on forever, doesn't end. Okay? All right, so terminology. So what do these ones mean? So repeating decimals, which have a recurring pattern of digits. Non-repeating, which means they go on for a long time but don't. Terminating decimals, decimals a finite number of digits, means they stop, finite. Okay, means you can count it. And then non-terminating decimals are ones that have infinite digits that don't stop. Okay, so state whether decimal is equivalent to each other. Is repeating, non-repeating, or terminating, non-terminating. Okay, so we'll say R or NR, and we'll say T or NT, or we'll just put those instead of writing the whole word out. Okay, simple. Okay, so 1/8, we should know 1/8. 0.125, good, Josie. I think we had a poster about that one, didn't we? I think somebody did last year. We had a fraction poster. I think that was Elmer's group, actually. So it's 0.125. So repeating, non-repeating. Non-repeating. Terminating, non-terminating. Terminates. Okay, so that makes it rational. Let's write that yet. They're setting it up. 2 over 11. What is that as a decimal? What do you got, Brandon? 0.18 repeating? Like the 8's repeating or the 1 and the 8? Both. Gotcha. 0.18 repeating. So repeating, non-repeating, so it's repeating. And it is non-terminating. Whoops, not R, T. Good deal. Okay, 9 over 7. Mike, what's 9 over 7 equal? 1 point what? 2857. Okay, so would that be what? Repeating, non-repeating? 9 over 7. Let me see this here. No, that's right. Oh, that's right. That's the weird one where it starts repeating from here, I think. Yeah, you would have to go a little further. We'll look at it in a second. Keep doing that. It's non-repeating. So non-repeating, so maybe my notes are just wrong. Okay, so we'll go non-repeating, non-terminating. That's fine. Okay. Except for, it has to be one of them, because if it was that, it'd be An irrational number, I know it's not an irrational number. So let's trust me on this. We're going to say it's repeating, and I'll try to figure out how to prove that to you here in a second. But I do know it's an irrational number because it's an integer over an integer. Integer over integer is the definition of a rational number. So we'll have to see if we can get that to more places in your calculator or something. Okay, 0.94 repeating, so we know that's repeating, and it's non-terminating. Root 8. Okay, that's going to be 4 root 2 was what that, or excuse me, 2 root 2 is what that breaks down to. Just, we don't know that yet, but 2 root 2. Well, it's got a root 2, which is going to make it that non-repeating, non-terminating, because root 2 is an irrational number. 0.16 square root is going to give us non-repeating and terminating. Very good. All right, so now let's get into the actual definition of rational and irrational numbers. So decimals, numbers which repeat or terminate, can be converted into fractions. These numbers are called rational numbers. So if they repeat or terminate, either or, repeat or terminate, they are rational numbers. Okay? Decimal numbers which are both non-repeating and non-terminating cannot be converted to fractions. They're called irrational. So 9 over 7, that's a fraction. So I know that's why I can tell you that that one has to be repeating or something, because it has to meet one of these restrictions. 9 over 7 can't be non-terminating and non-repeating. Okay, so like I said, we'll look at that in a second. All right, so here's your basic definition for rational and irrational. Is there any questions on that? How to tell the two apart? Again, what should you think about irrational? They're very what? They're very rare. There's not very many of them. Okay, so don't think it's like 50-50. It's not like some are rational, some are irrational. Okay, it's more like 99% is rational, 1% is irrational. Probably even less than that. Okay, all right. Identify each of the following numbers as rational or irrational. So 1.493, is that terminating? Yeah, so I mean it's rational. Okay, how about root 5? Probably not. Okay, yeah, it's non-repeating. Okay, and it doesn't terminate. Okay, C, it's repeating. Okay, so we know, so this one here is irrational. This one's rational. Because as soon as you see repeating, you know it can be a fraction. Okay, this one here, square root of 81. What's square root of 81? 9, which is negative 9. That's rational. It's a whole number. So it's terminating and it's non-repeating. Okay, square root 4.41 will get you 21 over 10, okay, which is rational. It terminates. That's why. It's non-repeating, but it terminates. Okay, look really closely at F. You may think it's repeating, but it's not. Okay, it has a pattern that still doesn't meet the restrictions. So it's non-repeating, non-terminating. The dots mean it's non-terminating, and it's not a consistent pattern. Fair? This one is irrational. Non-terminating, non-repeating. Okay. All right. Example 3. Order the following irrational numbers on the number line. Okay, so we're going to order them. So root 14. Well, root 14 is really close to square root what? Yes, but that doesn't help us. Is 15 a perfect square? No. Yeah, about 16. What's square root of 16? So this is fairly close to 4, right? Thank you. So I'll put it right about there. Let's call that A. Okay, pi starts out with 3.14. So right here should probably be B. Root 80. Well, what's that really close to as a perfect square? 81. What's square root 81? So it's just under 9. Okay, root 15 is really close to, I talked about 16, right? Square root of 16 is 4, and then times that by 2. So it's almost going to be 8. This is almost a 4. So we're timesing almost a 4 by 2, so it's going to be almost an 8. So I'm going to put it right here. And the last one, square root of 0.1. Square root of 0.1. Well, that's 1/10. Square root of 1 is 1. Square root of 10 should be like 1 over what? Probably pretty close to 0, huh? So it's going to, what is it? Okay, so yeah, right there is good. Perfect. 0.316. Okay, and then just, that was all just by estimating, okay? Let's go out and just, if you want to just, here's, that was 3.741. That's 3.141. That's 8.944. That's 7.745. And then 0.316, like Josie said. Very good. Okay, now, so we're teaching you how to use your calculator throughout your next few years in math. Okay, so these things are pretty powerful. Use a graph calculator to convert each of the following to an improper fraction in simplest form. Okay, so what you can do is as soon as you get, like if you do on your calculator, if you get a decimal, you can always hit math fraction and it'll turn it back into a fraction. Okay, that's what this is telling you to do. So, for example, 0.36 repeating, you could put that a few times on your calculator over and over, and you can hit fraction, and it should put it to the fraction it's supposed to be. So mine just did 4/11, just like this. So same thing for 3.95 repeating. Just hit a bunch of 5s, hit enter, math, fraction, enter. What'd you get for that one? 178 over 45. Now try it. Just hit fraction, hit math. Just do a little more. Okay. Let me see. Yeah, because you have to do more 5s. Yours might just be, I don't know why you're just doing that. I might look at yours. Yeah, some of them don't. Yeah, you had it. So type 3. Put this, Breezy, put this in your calculator. Just put 170 divided by 45. Okay, and then hit math fraction again and see if it puts it back there for you. Yeah. Huh? Well, your calculator's just rounding it. It's okay. You got it? Okay. All right, so some of our calculators are newer than others. It's okay. All right, let's finish this. We got one more page, and I'll go get a break, so don't take the break yet here. Okay, so converting repeating decimals to a fraction algebraically. Okay, so this is actually, I think, somewhat interesting. We do this in actually calculus, but. All right, so step 1, let x be the original number. Okay, step 2, identify the digits which repeat. 3, multiply both sides in step 1 by a power of 10, which moves the repeating part to the left of the decimal point. Okay, if necessary, multiply both sides in step 1 by a power of 10, which moves the repeating part to the immediate right of the decimal point. So we're just going to go through these steps. I'm just kind of reading through them. Subtract the equation in 4 from the equation in 3, and it'll get you what your answer is for x. So let's just go through this here. We're just going through the steps above. we're going to do the steps now. I just read steps, so I didn't tell you anything. All right, so number 5. It says let x equal 2.051 repeating. The repeating digits are 5 1. So step 2, identify that. Step 3, to move the 5 1 to the left of the decimal point, multiply by both sides of step 1 by a. So what place is the 5 1 in? It's in the thousandths place. So we're going to multiply that by 1,000, 10 to the third, okay? And see how it moves the 5 1 over? So we had 2.051, and we multiplied by 10 cubed, 1, 2, 3, so it gave us 2051.51. Repeating. Since we did that, it's now 1,000x equals 2.051.51. Okay. Step 4, to move the 51 to the immediate right of the decimal point and multiply both sides in step 1 by 10. Okay. So the immediate right. Gotcha. Okay. And multiply both sides by 10. Whoops. Okay. And all the reason is that in this step 4, now pay attention, step 4 and step 3 are different. Okay, they're different steps. They're not one step, they're different because they're doing that to get these like. Okay, so what you're going to do is you have 1,000x equals this and 10x equals that. And what we're going to do is we can subtract equations, and we'll learn this with, you'll do this more when you're doing system of equations, but we can subtract equations. So you go 1,000x minus 90x, or 10x, gets you 990x. This minus this, and the reason, why does this help us? Because it minuses that repeating off. That's why it helps us, because the repeating goes away. Okay, so we're going to get 2031. Then we divide it over there. X equals 2031 over 990, which reduces, your calculator can do that for you, 677 over 330. So if you put 677 over 330 in your calculator right now, it should kick out 2.051 repeating. Okay? We're going to do 2 more together here, so I know that was probably the most confusing part of today. Let's do 2 more together. Okay. All right, so step 1, x is going to equal 0.36 repeating. The repeat digits are 0.36, so that we're going to do 10 squared. So we're going to go 100x equals 1236.36 repeating. Okay, so then we're going to move the 36 to the immediate right. Let's see here. Or excuse me, we don't have to, sorry. We only had to do that step for the 10 to move it so there wasn't a 0 in the way, because it didn't start repeating that last one. The one we just did, there was a 0 between the 0.051 repeating. The 0.36 is immediate, so we don't have to do that. We can just say this. We could just go right now and minus, because we can just go right straight down. Okay, so here, let me just write down on the bottom what I'm talking about from the last one. The last problem had this. The 5 1 was repeating, but we had to get this out of the way, so we had to move it over 1 spot. 1 spot was 10. That's why we multiplied by 10x for our step number 5. Today, or this problem, still today, okay, we can just do x. So now we can go 100 minus 1x is 99x. The 3 6's cancel. I get 36. And then you're going to get x equals 36 over 99, which reduces to 12 over 33. Oh. Misdivided that, sorry. 4 over 11. 4 36. I could still go 12 and 33 more. Okay, so 411 gives you 0.36 repeating. All right, let's do one more here. And this one we're going to have to do the step I was talking about with the 10x this time, because there's a 9 in the way, because it's a 5 repeating. So x equals 3.95 repeating. Okay, again, we're going to go 100x because it's the second place. Okay, so we're going to go 100x equals 395.9, excuse me. Yeah. 0.5 repeating. Okay, and then we're going to take our original and we're going to multiply it by 10 just to shift that 9 over so the 5 is on the end again. So we need the 5 on the end so they cancel. So it's going to be 10x equals 39.5 repeating. Now the 5 repeatings are lined up and they're ready to eliminate. So now we're going to subtract. That goes away. I get 90x equals 56. And then divide by 90. Your final simplest answer is 178 over 45 for this fraction. And that's the one we did from the beginning, right? All right. Okay, so I'll give you guys a couple minutes here, and we'll talk about the second one here.